Hello friends, you are watching channel Number Collage. Through this channel, we take sincere efforts to make you understand and like mathematics, science and engineering in a simple and easy manner. In this video, we will discuss non-concurrent force system in which we will talk about ladder friction. In non-concurrent force system, the forces do not pass through a single point, so that in the state of equilibrium, we need to apply summation of horizontal forces equals 0, summation of vertical forces equals 0, and summation of moments about a point equals 0. A ladder of length L is resting on a rough floor at a point B. It is leaning against a vertical wall at point A. Its weight W acts vertically downwards through G, which is its center of gravity. NW is the wall reaction on the ladder, which acts towards left and is perpendicular to the wall. NF is the floor reaction on the ladder, which acts vertically upwards and is perpendicular to the floor. Fw equals mu Nw is the frictional force between the ladder and the wall. Fw acts upwards along the wall because the top end of the ladder has tendency to slip down the wall. Ff equals mu Nf is the frictional force between the ladder and the floor. It is directed towards right because the bottom end of the ladder has tendency to slip towards left. A ladder of weight 290 Newton and length 6 meter is leaning against a wall, making an angle of 50 degrees with the wall. The coefficient of friction between the ladder and the wall is 0.33. Calculate the horizontal force required to be applied at the bottom of the ladder to stop it from slipping. This is what we have to find out, value of P. Now we shall find lengths of moment arms that we shall need. AC equals AB cos 50, which equals 6 cos 50, that will be 3.56 meters. AC 3.56 meters. BC is AB sin 50, which will be 6 sin 50, that will be 4.60 meters. BC 4.60 meters. Then we shall need BD, which will be AB divided by 2 sin 50, 3 sin 50, which will be 2.30 meters. So BD 2.30 meters. In equilibrium, we have summation of horizontal forces equals 0. So P minus NW, which will be 0. P is the force required. NW is the normal reaction given by the wall. This will be P equals NW. Now we have Fw equals mu Nw. That is the frictional force between the wall and the top of the ladder. We have mu equals 0.33, so this will be 0.33 multiplied by P, that will be 0.33 P. Summation of moments about point B is equal to 0. So that will be W multiplied by BD, W multiplied by BD. It will give clockwise moment, NW multiplied by AC, NW multiplied by AC. That will give anticlockwise moment, so it is negative. FW multiplied by BC, FW multiplied by BC, that will give anticlockwise moment, so it is negative. We will substitute the values 290 for W, 2.30 for BD. NW equals P. AC is 3.56. FW is 0.33 P. And BC is 4.6 equals 0. So 290 multiplied by 2.30 will be 667 minus 3.56 P. 0.33 multiplied by 4.6 will be 1.58 P equals 0. So the addition of these two terms will be 5.14 P, which will be equal to 667. So P will be 667 divided by 5.14, that will be 129.76 Newton. So that is the value of the horizontal force that should be applied at the bottom of the ladder to avoid it from slipping. One end of a uniform ladder weighing 35 Newton rests against a smooth wall. Because it is smooth wall, coefficient of friction mu is 0, and other on a rough ground. So this is the rough ground whose coefficient of friction is 0.3. Find the inclination of the ladder to the horizontal, that is theta, when it is on the verge of slipping. In the state of equilibrium, we have summation of horizontal forces equals 0. We have the horizontal forces FF minus NW equals 0. FF is the frictional force between the ground and the bottom of the ladder. NW is the normal reaction by the wall on the top of the ladder. FF is mu NF minus NW equals 0. Mu is given to be 0.30 and NF is normal reaction by the floor on the bottom of the ladder. So mu NF becomes 0.3 NF. That gives us NW equals 0.3 NF. We also have summation of vertical forces equals 0. Now the vertical forces are NF minus W plus FW equals 0. Mu equals 0 because the wall is smooth. W is downwards weight of the ladder. We have FW equals mu NW, but since mu equals 0, 0 multiplied by NW becomes 0. So we have FW equals 0. So we get NF equals W, but W is 35 Newton. but we have already obtained NW is equal to 0.3 NF here. So we get 0.3 multiplied by 35 because NF is 35 Newton, which we have obtained here. So this gives us 10.5 Newton. So we get NW equals 10.5 Newton. First we find out some moment arms. Those will be required. The first is length BC, which will be L sine theta, where L is length of the ladder. So BC will be L sine theta. ED, which will be L by 2 sine theta, because G is the midpoint of the ladder. So length AD will be L by 2 sine theta. Now since this is non-concurrent force system, we will apply summation of moments about a point equals 0. So for that we will use summation of moments about point A. So we will have W multiplied by AD minus NW multiplied by BC equals 0, where W is downwards from G and NW is the normal reaction by the wall on the top of the ladder. So that will be W multiplied by L by 2 cos theta, where AD is L by 2 cos theta, and BC is AC sin theta. W is 35 and NW is 10.5. So 35 divided by 2 will be 17.5 L cos theta minus 10.5 L sin theta equals 0. So we get 17.5 L cos theta equals 10.5 L sin theta. We will take sin theta divided by cos theta equals tan theta. So that will be 17.5 divided by 10.5, which will be 1.666. That gives us theta equals tan inverse of 1.666. So we get theta equals 59.03 degrees, which should be the angle of inclination of the ladder with the ground to avoid slipping. So this theta will be 59.03 degrees. So this is about ladder friction and some basic problems on it. If you like this video, please subscribe this channel by pressing the subscribe button. Thanks for watching. Have a nice day.